Hello, my name is Nathan Hauk. I work for H2O Solutions, and today I'd like to show you how to calibrate a 4000 or 5000 TOC with an M300 meter. To start off with, I'd like to show you all the tools that are necessary. First of all, you'll need the calibration kit. You will need the 4000 TOC or 5000 TOC instruction manuals. You'll need all the hardware necessary for mounting the injection pump. You'll need the injection pump itself, the power adapter for that. You'll need the key to open up the 4000 TOC unit. You also need the connectors for the pump, a new filter, and the calibration and suitability sheet, the UV lamp replacement kit from Toledo Thornton, and the Thornton Toledo calibration solutions. To start your calibration process, you'll have to put the pump assembly together. Using the hardware that's given with the unit, we have to assemble it so that the pump will sit on the unit and the calibration solution will sit there as well. Take this flat piece, lay that over top of the unit here. The next piece that you want to use is this piece here. It has two rubber feet on the back of it. Those go up against the unit and up over top of these screws like that. Next thing to mount is put the pump on. The pump goes on the left side of the unit and then tighten that screw down. Then you have this piece here, and that's to hold the calibration or the suitability solutions. Place that over top of that screw assembly and tighten down. Next, take this tube connector and place it on the inlet side of your pump. This will be drawing from the solution bottle into the pump assembly. Then place the other one that's given to you on the outlet side. And this pumps the solution from the pump into your unit. Take the other end and place in the side of your unit into your filter housing. Tighten down and make sure that there's no leaks. Now connect your adapter to your pump and plug in. Now with the calibration, we have two different kinds of calibration solutions. The first one is the actual calibration solution when we do the calibration. The second is a suitability solution that we use to make sure and verify that the unit is properly reading different kinds of TOC levels. So we have, in the first kit, we have 4 solutions. We have the 2 solutions that are considered blank water. That's water that we can use that's low parts per billion, but we can use it to test the pump or other things. It's not integral in the calibration process. The next one that we have is a 503 part per billion solution made of sucrose. And then we also have a 253 part per billion sucrose solution. And these are our 2 calibration solutions that we'll be using. And then you also have inside the certifications that are certifying the actual quality of the water from the lab that it was created in. So the first thing we're going to do is take the 500 part per billion calibration solution. It's actually 503 parts per billion. And we're going to open that up. This is the first solution that we want to test and also the one that we're going to use for calibration. I also recommend that you use the blank water solutions if you have a feeling that the pump may not be working properly, or if you're trying to make sure that the unit has proper flow. Use the blank water first so that you don't use up the calibration solution, because once you use it up, you no longer have any and you've just ruined a calibration. So start off with 500 part per billion solution. This is 503. We're going to open that up and we're going to place that in our on our TOC unit. Once it's been placed on the unit, turn on your injection pump and let it begin to flow through the unit. Make sure that you have proper flow and set up your flow inside of your M300. I will show you how to do that next. With the injection pump on, go into your M300 unit, go into menu, scroll down until you see set flow rate. Hit enter. It says set flow rate, and off is flashing. Press the up arrow. It'll say on, hit enter. When you do this, you'll see lights that will appear on your 4,000 or 5,000 TOC unit. These lights indicate the level of flow. At 20 milliliters of flow, all 4 lights should be lit. When you have a low flow, your lights will go down toward the bottom and the top lights will disappear, signaling that you have low flow on your unit. Turn your needle valve to the left, counterclockwise, to open your valve to increase the flow. If your flow is too high, your lights will start disappearing from the bottom and go up to the top, signaling that you have high flow. Turn clockwise to close your valve down until you get the proper flow where all 4 lights are showing. You may need to play with the unit for a little while to get the flows to level out. Once the flows have stayed at 4 lights that are lit consistently for a couple seconds, go back into your set flow rate and change it back to off. At this point, you're putting your unit back into operation. Exit that menu by hitting menu and cal together, and now your unit is operating as it should. Also verify that your UV lamp is on. The next part of the calibration is to verify the level of parts per billion that the meter is currently reading before calibration using the 503 standard solution. You may need to wait 5 or 10 minutes for it to stabilize, but don't wait too long. Always take note of how much solution you have left. You should never go below a half a bottle of solution when performing this, because you'll still need more solution to perform the calibration after that. Once your solution has stabilized, which this has at 417 parts per billion, write that number down as your as-found data for your TOC. Once you subtract your as-found data from what it's supposed to be, the reference TOC 503, you have a limit of plus or minus 50 parts per billion. Then it asks if adjustment is required, and with this unit, yes, an adjustment is required because it is below. It's at 417 and it should be reading 503 parts per billion. Before opening the unit, be sure to power it down so that you have no electricity going to the unit. On the left-hand side of the unit, there's an access cover that must be removed to gain access to the lamp assembly. Remove that. You can remove it with a flat-end screwdriver and then the rest of the way with your hand. And then proceed to the front cover. The front cover of the unit opens up when the hex nuts are loosened up on the side. Open up the hex nuts with the Allen key that's provided and swing the bay door open. Once the door is open, you will have access to the UV lamp and the black retaining nut that you'll have to turn counterclockwise to loosen, and that frees the UV inside of the sleeve. Unplug the UV from the front of the unit, thread the cord through the side, through the access panel, and gently and slowly pull the UV unit from the sleeve on the inside. To install the new lamp assembly, remove the assembly from its packaging, being very careful not to touch the new bulb with your bare hands. Gloves are provided for you inside of the kit so that you don't get the bacteria from your hands on the new UV lamp. Remove the new UV lamp from the sleeve. And the installation is the reverse of removing it. Put it back in through the side, into the sleeve, and then tighten down, turning clockwise, the black retaining nut. After tightening it down in its sleeve, take the cord and thread it back through the access panel and reconnect it to the connector in the front of the panel. Now the UV lamp is installed in the kit. Close up the unit, 4000 or 5000 TOC unit. And replace the access cover on the side of the unit. Do not over tighten it or you'll crack the plastic housing. After replacing the cover, make sure you put a service sticker on it so that you know, and label and date it so that you know when the lamp was last changed. Before we start our calibration, we do need to go in and reset the lamp hours on our M300 unit to signify that we replaced a UV lamp. To reset the lamp hours, go into Menu, go to Configure, hit Enter, then go down to TOC Setup, hit Enter. You'll see different choices. There's Auto Balance, TOC General, and then Lamp Control. Go into Lamp Control, hit Enter. They'll ask you for your UV lamp off. Right now the UV lamp is off because we have been working on the unit. So we're going to turn the lamp on, hit Enter, and then it asks you for the amount of hours. It should be 4,500 hours for this unit. So we're going to hit Enter, and then it asks you for lamp time reset. That's to reset those total hours to 4,500 hours. We want to scroll up to Yes and hit Enter. It says Save Changes, press Yes and exit. Press Enter to exit. So we're going to hit Enter, and now it's going to reset the hours for us. After removing the filter assembly from the unit, open the filter assembly, and inside you should find a brass washer, a spring, and the old filter. Replace the old filter with the new filter, reinstall your filter, then your spring, then your brass nut, and your end. Tighten down and reinstall, making sure that you have the direction of flow going into your unit. Tighten down and ensure that there are no leaks. Now you're ready for calibration. Go into Calibrate, into your M300, and it'll ask you whether you want to calibrate the sensor or it gives you other options. We're going to calibrate the sensor, so hit Enter to calibrate the sensor. With this calibration, we want to perform a multilinear calibration. So we will go into Type, Multilinear, and hit Enter. Now it's going to ask you to set your flow and then readjust your meter so that you can check your flow. Verify that your flow ratio is correct. If not, you need to adjust it until all 4 lights are lit. Once it's properly adjusted, press Enter. Now it'll ask you what your 0.1 calibration is going to be. On this unit, we're going to change it to 503 parts per billion. That's the solution that we have that it's certified at right now. Then underneath it shows you what it's currently reading, which is 406 parts per billion. That's adjusting a little bit. And you will have some variation, a little fluctuation as you're performing this. Once your solution stabilizes, press enter to perform the calibration. Next, it will ask you to set a new flow rate. You have to stop the 500 solution. Now you want to put the 253 parts per billion solution in and let that stabilize. Once your reading is stabilized, readjust your flow, making sure that you have all 4 lights on, then press enter. It will now ask you what your point 2 is. Enter in 253 parts per billion. And right now it's reading 233 and hit enter. This will perform the second part of the calibration. Now it's showing you your multipliers and your adders. Multiplier 1, adder 1, it says press enter for more, hit enter. Shows you multiplier 2 and your adder 2, and asks if you want to save your calibration. Hit yes, and that will save the calibration inside the M300 unit. If you hit no, it'll clear out all the calibration and you'll have to start all over again. So you're going to save calibration, hit yes, and say please wait. And then your calibration is successful, press enter to continue, hit enter, and now your calibration is performed. The next step is to place your solutions back online. Put your 503 part per billion back online and test it to make sure that it's reading within the limits of plus or minus 50 parts per billion. Then after doing your 550, place your 253 back online to verify that it's reading within a plus or minus 25 part per billion limit. Record those values to verify that your calibration has been successful. The next set of solutions are for your suitability test. They include 4 solutions. You have 2 that are reagent water. They are less than 100 parts per billion. And then you have a 500 part per billion solution that's made from sucrose. And then another 500 part per billion solution that's made from benzoquinine. Those are the solutions that are needed for this calibration. You start off with the reagent water solution. Before performing this calibration though, you may need to reset up another channel on your M300 to show conductivity as opposed to resistivity or another measurement that may be located on it. To do this, go into your M300 and press menu. Then scroll down or up until you get to configure. Hit enter, then it'll say measurement, hit enter, then it says channel setup, hit enter again, and then parameter. The parameter is TOC because the sensor is located within the TOC unit. Hit enter again, and now it will give you different channels. You see A, B, and then as we continue down you would see C and D. Right now channel A is set up for TOC. That's reading it in parts per billion, and that's your channel A located here on the top. Channel B was resistivity before, and I changed it to conductivity. To do that, scroll over and keep pressing the right button until channel B is highlighted and flashing. Right now you have it flashing here. You can adjust it to your different parameters, degrees Celsius, degrees Fahrenheit, lamp remaining, that you can enter your own in, TOC, GCL, and then you have resistivity here, and now I'm back up to conductivity. Now conductivity right now is reading auto, so it's going to read nanosiemens or microsiemens or so on and so forth. It will adjust on its own. To prevent that from happening, because you want to be reading it in microsiemen, we're going to scroll over to auto and then hit the up or down arrows. Hit the up or down arrows to readjust it to whatever you want it to be, micro or milli or units. Back to auto. We want it to be in micro, so it's reading microsiemen. Then hit enter. Now it will give you channel C and channel D. You don't need to adjust these channels because we only need to see that one reading on either channel B, C, or D, and it doesn't matter which channel you set it up on. Hit enter again, and it's going to ask you if you want to save your changes and exit. Press enter for yes, and it'll save your changes and exit, and now you'll be reading conductivity here. The reason we need to do this is because on the suitability sheet, the calibration sheet, you will see that we need to write down what the conductivity is for each of the standard solutions that we're using. So now we're going to start off with the reagent water. I'm going to connect that up, and I'm going to start our pump, and we're going to see what it's reading. Be sure to readjust your flows after installing any new solutions. Let's go into your menu, scroll to set flow rate, hit enter, go up to on, and then it'll show your flow rate, so you can see our flow rate is correct. Go back down to off, and you can exit that menu. So you can see right now that our first standard solution, the reagent water, is reading 6 parts per billion, and we're reading it at 0.64 microsiemens. So our first recording will be 6 parts per billion at 0.64 microsiemens per centimeter. After taking 3 readings, record those, and then average those 3 readings together. So we had 6, 5, and 5. We're going to average those, and we're going to get an average of 5. Write that down, and then move on to your next solution. The next solution is going to be the 500 parts per billion sucrose solution. Alright, and this is my last reading, 553 parts per billion. My second reading was also 553, so that's going to give me an average with 554, 553, and 553 of 553 parts per billion. So I'm going to write that down on my paperwork, then I'm going to do the math on what the response calculations are and the response efficiency, and find out what my percentage is and see if it passed the suitability test. The last part of this video that I'd like to show you is how to fill out the calibration sheet that we have here at H2O Solutions. The first part of the calibration sheet is our customer, and then the location of the system, and then the date of the calibration. Then fill out your meter information with your model and your part number. The model number here was the M300, and then there's a serial number. The ID tag is if there is a system-specific tag that has, let's say it's sensor 101 or conductivity meter 203, whatever it may be, write down the ID tag number for that. Then next is the calibration due date of when the next calibration from the current calibration is due on the meter. Then on the other side, this is for the TOC unit, and it also has all the same information. Most of that information, or all of that information, will be found on a sticker either on the side or on the top of the unit. Then you're writing down your as found TOC data. The first is the first test we did with the 503 part per billion, where the as found value, and the next was the subtraction of those values to find out if we were within limits, and we were not, so we did require an adjustment. So we wrote yes on there. Then this here is the multiplier and the adders before your calibration. This is the as found data before you perform a calibration, also the amount of lamp life hours that were left at the time of your calibration before you reset the timer. On the bottom, this is your actual calibration. This is your solution that you started with. This is what it was reading after the calibration, and then this is the difference between that and whether it was within limits. If it was within limits, we write yes on both sides here, and the calibration passed. If not, then the calibration was not successful. Then you write down the TOC calibration factors after the calibration, and you're writing down your multipliers and adders on the end of this page. That page is for the calibration. On the back side of this page is where you will find all of your information for the suitability test. You have the same information located on the top of the page. The next boxes here are the different readings that we took. First column is for the reagent water that we used, your first reading, second reading, third reading, then your average reading where you take all 3 of those, add them, then divide them by 3. Then your conductivity reading, and that's not an average, we just take that one time during the test. Then the same thing for sucrose and benzoquinone, and then you come down here to your response calculations. At your response calculations, if you notice, they're correlated to RW for reagent water, RS for sucrose, and RSS for the benzoquinone. If you come down here, you'll see how to enter it in with your calculations. So we put 509, which comes from the sucrose, minus your reagent water, 5, and then you get 504 parts per billion. And then we come up here with the benzoquinone and take 553 and subtract 5 parts per billion out of that and get 548. Now we move down here and basically have the same exact equation just in a different box, but now we're finding out what the efficiency calculation was, or our response efficiency, and you see that it worked out to being 92%. What we did is we took 504 divided by 548 to get 92%. And then we see on the bottom, it asks if your reagent water is below 100 parts per billion, because it needs to be as part of the calibration, and yes it was, we were at 5. And then is the efficiency calculation less than, 85%, is it greater than 85%, or is it lower than 115%? If it was, then yes, and we also then it passed the suitability test. If it's below 85%, if it's 84 or below, or if it's 116 and above, then it didn't pass the suitability response efficiency test, and either the meter itself may need to be replaced, the sensor may need to be replaced, or the calibration may need to be redone because it's not reading properly. And then at the bottom, if you notice, we also wrote on the remarks that the calibration was performed successfully. Also, if you notice on the bottom of the page, we wrote that the calibration was performed successfully. That way the customer knows that everything went well, that there was no problems with the calibration, and that their meter is up to date.